Hi everyone, welcome to the second lesson of week 5. This is going to be covering solving quadratics using quadratic formula. So the lesson that you just watched was over solving with square root. This is just another way to solve a quadratic equation. The way that this looks, you'll notice, is a little bit different than what you looked at on the previous video. Notice how you have 3 terms on your equation. In the other video, most of them only had 2 terms that was already equal to 0, or maybe you had 1 term on each side. Now you have 3 terms. So whenever you have 3 different terms, when you're solving a quadratic, I want you to think about either factoring it or using quadratic formula. In this case, we're going to use quadratic formula. So remember that the first number, I'll zoom in on this one here for you. The first coefficient that you see, this is A, this is B, and this is C. So the equation that you're using is right here. And basically you're just going to go through and substitute A, B, and C with your different values. So my A value is 3, my B value is 5, and my C value is -12. Pay attention to the sign, the positive or negative sign that's in front of that number. You want to take that with you when you're listing the value. So this is B. I'm just pulling this from the formula. Okay, so I'm going to go through and replace. So my B value is 5. My B value again is 5. My A value is 3. My C value is -12. And my A value is 3. Okay, I want to simplify this to make it as organized as possible. So what I'm going to do over here is I'm going to find what's called the discriminant. Okay, the discriminant is the square root of b squared minus 4ac. So it's really just the part of the quadratic formula that is in that square root symbol. That's all that is. Okay, we're just going to simplify that first. So in our case, this is the square root of 5 squared minus 4 times 3 times -12. You can either type this in the calculator or you can calculate it by hand. If you do it by hand, 5 squared is 25. -4 times 3 times -12. There's 2 negative signs, so it's going to be a positive. 4 times 3 is 12, times 12 again is 144. Okay, so if I add these together, I'm going to get the square root of 169, and the square root of 169 is equal to 13. So that means that this entire section of my formula is really just 13. So I'm going to rewrite this. I'm going to have the -5 in the front, plus or minus. Instead of writing everything in blue, I'm just going to replace it with 13 over 2 times 3 is 6. So I'm going to break this into 2 separate fractions to kind of separate everything out. So your 2 fractions are -5 plus 13 over 6. -5 plus 13 is going to give us a positive 8 over 6. I can take a 2 out of 8 and a 2 out of 6. So 8 divided by 2 gives me 4, and 6 divided by 2 gives me 3. So 4 over 3 is one answer. The other fraction is going to be -5 minus 13 over 6. So I just changed that positive sign to a negative sign to represent the plus and the minus. So -5 minus 13 is going to give me I'm going to write it down here, -18 over 6. I can take a 6 out of both of those, or you can just think of it as 18 divided by 6. It's going to give us -3. So I got 2 different solutions. They're 4 over 3 and -3. Okay, now I'm going to go through some of the ones that are on the bottom here. So I'm going to identify A, B, and C. So I've got my A value is 2, my B value is 5, and my C value is -8. The first thing I want to calculate is the discriminant. So I want to find the square root of b squared minus 4ac first. Okay, so that's going to be 5 squared, because b is 5, minus 4 times 2 times -8. So this is b, this is a, this is c. 5 squared is 25. 4 times 2 is 8, times 8 again would be 64. And since I have these two negative signs, it's going to turn into a positive 64. Okay, so 25 plus 64 gives me 89. Okay, notice that this is not a perfect square. I can't take the square root of 89 and get a whole number back. So we're just going to leave it as the square root of 89. So I'm going to go ahead and rewrite my formula. Okay, so the piece that we just found, that square root of 89, that's what's going to be replacing this piece here. And then everything else is going to get replaced with what we have at the top. So negative, my b value is 5, plus or minus, I'm going to replace the blue with the square root of 89, and then divided by 2a, a is 2. Now let's simplify. So I'm going to have negative 5 plus or minus the square root of 89 divided by 4. So I'm going to break it off into two different answers. We're going to have negative 5 plus the square root of 89 over 4, and negative 5 minus the square root of 89 over 4. Okay, so those are your two solutions. Let's take a look at the second one. So my a value is 2, my b value is 8, and my c value is 8. They're all positive. I'm going to find my square root of b squared minus 4ac first. So b is 8, a is 2, and c is 2. Or sorry, c is 8. So we're going to have the square root, 8 squared is 64. 4 times 2 is 8, times 8 again is 64. There's a negative sign in there, so this is going to be minus 64. So 64 minus 64 is 0. So what I have here is the square root of 0. Well, the square root of 0 is just 0. Okay, so I'm going to rewrite my formula. So the portion in blue, this is the same thing as what's in blue here, this whole square root. So I'm going to rewrite and replace everything. Negative b is 8, plus or minus, that entire blue section is now 0, over 2 times a, and a is 2. So I don't really have to write the plus or minus 0, because if I add or take away 0 from something, it doesn't change what's there. So this is going to become negative 8 over 4. Well, 8 divided by 4 is 2, so this is going to become negative 2. So in this case, you only get a single answer, and that single answer is negative 2. Now, you could write this as negative 2 plus 0 and negative 2 minus 0. We call that having a multiplicity of 2. Multiplicity means how many times does the solution appear. So your answer is negative 2, or x equals negative 2, but it is going to appear twice on the graph. So you're going to have like a bouncing look to the graph at that point where x is equal to negative 2. But when you write your answer, you just need to write it one time. Okay, let's look at the last one. So my a value is 3, my b value is negative 8, and my c value is 10. I'm going to find the square root of b squared minus 4ac. So I've got b squared, b is negative 8. If you are going to type this in on the calculator, you need to make sure that you're putting parentheses in all the places that I am. If you don't put parentheses, it's going to give you the wrong answer back. So negative 8 squared, that's negative 8 times negative 8, is a positive 64. 4 times 3 is 12, times 10 is 120. So this is going to be minus 120. So this is going to give me the square root of negative 56. Now, for the purposes of this week, we are not looking at imaginary or complex solutions. So whenever you see a negative underneath of the square root, I want you to say no solution. Or I guess we can change that. We can either say no real solution. There is a solution, it's just not a real number. It's an imaginary or a complex number, It's that thing with the I that we did earlier in the year, okay? So negative under a square root, we're going to say no real solution. On this next page, the bottom section where it says b squared minus 4ac is less than 0, I just want you to cross that out because we're not going to be investigating when that happens. We're just going to be looking at if your b squared minus 4ac, if your discriminant is positive or if it's equal to 0. A negative discriminant would give you an imaginary number, and we're not looking at that this week, okay? So here, we're going to go through and identify a, b, and c. My a value is 1. Even though there's nothing written in front of x squared, there's really a 1 there, so my a value is 1. My b value is negative 4, and my c value is negative 3. So if I wanted to find b squared minus 4ac, I would have b, which is negative 4 squared, minus 4 times a, which is 1, times c, which is negative 3. So negative 4 squared is negative 4 times negative 4, which is positive 16. Then I've got 4 times 1 is 4, times 3 is 12, and I have 2 negative signs there, so that's going to be a plus 12. So we're going to get 28. So this value is bigger than 0. So over here where it says b squared minus 4ac is bigger than 0, that's the situation that we're in. So if you look at your graph here, we've got 1, 2. These are called zeros. You could also call them x-intercepts, or you could call them roots. So where it says zeros, I have 2 of them. And how many real solutions do I have? Well, I have 2 x-intercepts, 2 zeros, 2 roots. We can also call those solutions. So I've got 2 solutions. So the number of zeros that you have is the number of real solutions that you have. Let's look at the next category. So this time, my a value is still 1. My b value is positive 2, and my c value is positive 1. So if I find b squared minus 4ac, we're going to have b is 2 squared minus 4 times a is 1 times c is 1. So 2 squared is 4 minus 4 times 1 is just 4. 4 minus 4 gets us 0. So over here it says b squared minus 4ac is equal to 0. That's the situation that we're in. So looking at our graph, notice there's only one place where the graph is touching the x-axis. That means that we have one solution, one x-intercept, one root, or 1 0. So zeros, we're going to put 1, and real solutions, we're going to put 1. So those are the 2 cases that we're going to be paying attention to the most. Looking at the bottom, if the discriminant is a perfect square, so a perfect square is something like 4, 16, 25, 36, and so on. If you take the square root of those numbers and you get a whole number back, that's a perfect square. Then the solution is going to be rational. So let's say, for example, my answer is 2 plus the square root of 36 over, I don't know, 4, something like that. This would break, plus or minus. This would break into 2 plus the square root of 36 over 4 and 2 minus the square root of 36 over 4. Well, the square root of 36 is 6, so I'm going to get 2 plus 6 over 4, which is 8 over 4, which is 2. On this one, I have 2 minus 6 because the square root of 36 is 6 over 4. 2 minus 6 is negative 4 over 4, gives you negative 1. Those are both rational numbers, meaning they don't have an infinite amount of decimals behind them. If you put them in decimal form, that can't be rounded. It's a whole number, it's a rational number, okay? If the discriminant is not a perfect square, then the solution is irrational. So let's say I had the same exact thing, except this time, let's put the number 10 under the square root symbol. 10 is not a perfect square. If you take the square root of 10, you are going to get a decimal. So you're going to have 2 plus, in decimal form, the square root of 10 is 3.16227, blah, 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 over 4. And then you would have 2 minus the same thing. The 3 dots at the end just mean that it's going to keep on continuing forever. Okay, so these two answers are not rational because they have that decimal place behind them that's continuing on forever and never. Okay, so a square root, a perfect square under the square root symbol is going to give you a rational answer, and a number that's not a perfect square like 10 is going to give you an irrational answer. That is going to conclude this video lesson. So this is your last video lesson for the week. So once you have finished both of these lessons, I want you to make sure that you did the practice problems that were on the first page of your notes, the ones that were over solving square roots. Once you've done that, you can go ahead and start working on the assignment for the week. Thank you. Y'all have a great day, and thanks for watching.